Javed, you can start now.
Hello, Nagla.
Hello, sir.
Yeah. Just tell me in brief that what projects you have done and your relevant coursework.
I have done a project on 28 nanometer and 16 nanometer technology nodes.
Actually, do you have earphone? Like your voice is echoing. Oh, just
Is
tell
it
me.
clear?
Yeah. Okay. Continue. Just tell me your coursework and projects.
Yeah, I have completed my course in physical design domain, and I have done projects on 16 nanometer and 28 nanometer technology nodes. Basically, I look over floor plan and power plan stage. It is a block level implementation, and in one project, I have looked for sign off checks.
Okay. So you are targeting physical design. Okay. So next, Raghavendra, please tell me your project and coursework on which profile you are targeting.
Sir, I am mainly focusing on digital profile.
Okay,
I haven't done any project. I haven't done any good projects on analog profile. Right now, I have done the projects on this 16-bit pipelined adder. I have done that project, and elevator. Only those two projects, sir. Right now, I am doing second semester MTech at NIT Jaipur, sir.
Okay. And other than digital, you have completed like in Verilog, na? You know Verilog and others.
Yeah. Verilog. I know up to 70 to 75% a good command over the Verilog, sir. I have good
and
command.
You know STA, clock domain crossing.
Clock domain crossing, not that much confident, but STA I am confident, sir. STA, digital electronics, these things I am good at.
Okay. Hello, Bindu.
Hi, sir. Hello, good morning.
Good morning. So please tell me about your relevant course and projects.
Sir, I am currently doing MTech first year in NIT Kurukshetra, sir. I have did VLSI multiplier using PPAs, parallel prefix adders.
VLSI multiplier, okay. And other than that?
Sir?
Yeah, and only one project, sir.
Yes, sir. In BTech, I have done dual axis solar tracker using Arduino, but I have to go through it once again.
And relevant coursework like subject which in
Sir,
which
I'm Verilog. I'm good only, sir. And then STA, digital electronics.
STA and digital electronics. Okay. In first year, I think it's a good thing that you know. Okay. So, hello, Gopika.
Hi, sir.
Sir, please tell me about relevant coursework and your projects.
Sir, currently in the schools I have done Verilog, digital electronics, system Verilog and UVM. I'm yet to do projects.
Verilog, SV and UVM.
UVM. System Verilog and UVM I have basic understanding. I'm okay with digital electronics and Verilog.
Digital electronics and projects you have completed some.
I've done an internship with about an HDR module and a digital image processing module, but I have to go through it once again.
Actually, you are targeting for a digital profile, so digital design and verification. So mention project which is related to this particular domain.
I have to yet to do such projects, sir.
Okay. So now you have not done projects. Okay. So I'm giving task one by one. So Nagla, I'm starting from you. Okay.
Yeah. Okay, sir.
Okay. So I want you that take a pen and paper and draw the like CMOS. Okay. Then define the gain margin and phase margin, like no noise margin, no gate margin, and take a pen and paper and draw the CMOS VTC of voltage current transfer characteristic. So and after that you have to specify the noise margin, and then if you then you draw, then let me know. Okay.
Yeah. Okay.
Yeah. And Raghavendra. Hello, Raghavendra.
Yes, sir.
So I want to know you that take up Like, do you know about the blocking and non-blocking?
Yes, sir. Yes, sir. Blocking and non-blocking, sir.
Okay, okay. So first, take a pen and paper and
Okay, sir.
tell me about points in what is the difference between me, what is the FSM, okay, and what is the difference between melee and Moore machine. Write the 5 point at least.
Difference between melee and Moore machine, sir.
Yeah, yeah, yeah. Okay.
Okay, sir.
Hello, hello, Bindu.
Sir.
Yeah, take a pen and paper and write at least write difference between melee and Moore machine, and same for Gopika.
Oh.
Okay, and yeah, actually, I'm giving my contact number. When you done, just take a screenshot, snap, and send me, so that I can see it clearly. And maybe you have network issue on your side and maybe in my side. So take a snap and send to my number. WhatsApp me. So draw the VTC also, Nagla.
Sir?
Voltage transfer characteristics.
Yeah, okay.
Yeah.
Javed, one more student have joined. You can ask him. Anup.
Okay. Where? Hello, Anup.
Yes, sir.
Okay. Just tell me brief about what project you have done and what your relevant coursework you have completed.
Yeah, okay. Actually, I have done project on designing a RAM dual port and single port, and other project we have done vending machine, and a third project we have done is designing a FIFO synchronous.
And so you are targeted with design and verification design and
Yeah.
verification profile. Okay.
Yeah, actually we have completed system Verilog,
So-
but
so- Okay, no issue. So take a pen and paper and tell me about the difference between melee and moving machine.
okay, sir.
So like one person send me, and please tell me your name. Like send me difference between melee and moving machine in WhatsApp.
Gopika, sir.
Last digit at 235.
Okay, so how we can send?
Sir?
Yeah, Gopika, you have sent no?
Yes, sir.
I will. Who send me WhatsApp a pic of melee and moving machine, difference between melee and moving machine.
Yes, sir.
And you, somebody send me na. Who is this?
Sir, I have sent.
I have seen already.
Yeah, you. I know you. Okay, so Gopika, you send me. So, okay. Gopika, you think that your answer is correct? Hello? Are you confident that you write the thing in second point is correct? The second point. Yeah. Nagula and Raghavan and Bindu, what are you doing?
I'm sorry, sir. I missed it. I wrote and.
Sir, just now I saw your number, sir. Sir, if you want, I can show in the screen itself, sir.
Actually, I want to see the clarity in the maybe.
Okay, okay, sir.
Yeah. So.
Okay, sir. Okay.
Sir, I am sending, sir. Just a minute.
Okay.
Sir, I interchanged it, sir.
Okay.
Sir,
Yeah.
so how we can send the, can you provide the WhatsApp number?
Yeah, I have written on the chat box. Just check.
Okay, sir.
If you don't get it, let me know. I write again.
Sir, actually I have done late.
Yeah, I know. Okay. You get it? Actually, write your name also in WhatsApp, so I will recognize that who is the person sending.
Okay, sir.
Okay. Who write with pencil? Somebody. Okay, Rajendra. So Rajendra, do you think that only one difference is enough an interview to your good impact on interviewer? So,
Sir,
yeah.
So if you ask anything regarding that, I can explain, sir. But right now, I know a little bit, only this much, sir. I need to revise the concepts again, sir. Actually.
Okay. So, tell me.
Yes, sir.
Tell me what is the difference between melee and multi machine?
Sir, in melee machine, normally the number of states are less, sir, and output is depends on the present input applied and the next state. The output is depends on input and the present state. In more machine, output depends only on the present state, sir, but it is independent of input. But it requires more states than more machine has more states than the melee machine, sir. Normally.
Okay. So everyone is like melee machine have n state and Muri machine has n+1 state. Okay, so this is the wrong concept. First, I will tell you, and second thing, like your points is irrelevant, like a repeated point. Okay, the I can't find the conceptual clarity in your points, so please improve it. Okay.
Okay, sir.
Oh, yeah. So this is for everyone. Okay. You have just tried to like increase the number of points, but I can't find the clarity on your answer. Okay. So everyone is stating that Mealy have an state and Moore have n plus one state, which is totally wrong. If you go through any standard work, you find something different. Okay. So
Okay, sir.
I don't want to mention the name of people. So
Actually, I have sent.
yeah, let me come to your answer. Yeah, Anup. So you also okay, but I want difference, that this is not the way of writing difference. So okay, but there is more chance to improve it. Okay, no? Yeah.
Sir, so when we are differentiating, should we include the point of this
Yeah, point which are very like important. I found only one point in your answer which is relevant to interview point.
No,
Okay,
sir.
Nagula, I just wait a minute. Nagula, I told you that please draw the VTC. You didn't know what is the VTC diagram.
Maybe the combination of depletion type, enhancement type, all four.
No, I only want for the CMOS, like complementary metal oxide field effect transistor. Actually, we get the one curve like very famous curve. I don't know why you don't know. Okay, it's okay. So, like you you know about the low power design?
Yes, sir.
You are working on. So tell me that how at the in the architecture level we can reduce the power.
Yes.
Okay. Actually, how many ways of reducing the power in like in physical design? Just write those points and come to me. Okay.
Okay.
And other you people, I'm giving you one question. Okay.
Yes, sir.
Yeah, and just take a pen paper.
Sir.
Yeah.
Okay, so in case we want to improve this answer, like what other points should we improve?
I will complete those points after the interview. Okay. So this is the question one. My screen visible?
Yeah. Okay.
Yeah. This is the question one, and this is the part one. Okay. This is the part two. So right. So you have to just tell me that what is the answer, like what is the timing at the end, and what is star like hash 5 call. What is the difference between this one, okay, and this one? Okay. So everyone who is like Raghavendra, Bindu, Gopika, and Anup.
Sir, first one is the inter-assignment delay, sir. Second one is the intra-assignment delay.
Okay. So
Sir?
what is the intra-assignment delay and inter-assignment delay?
As you see in first code, sir, the hash 5 A is equal to B. B is assigned to A after a delay of 5 time units, and when B is assigned to A, then after.
Yeah, I told you. Okay,
sir?
Continue. Told you. Now.
Sir, in the first statement, between the value of B is assigned to A just after 5 time units, in the when the second statement C is equal to A starts to execute, that will be the delay of 5 time. After the 5 time units, when B is assigned to A is assigned to C. This is the first statement. Second statement tells that the value of B is assigned to A. That means between the assignment there will be a 5 time units gap, sir, like that.
Okay. Any other one to include?
So
Yeah.
In a first statement, and B is assigned to A after 5 nanoseconds, 5 unit delay. And in case and second statement, once it will be assigned to A after 5 delay unit, so then whatever the value of A, then again it will be assigned to C after 5 delay unit in the first. And in case of
the second one,
in A, the value of B will become after 5 delay unit to assign to A. There is a gap between 5 units between A and B. Then it will be assigned to A. And similar to the C, and the value of A will become.
What is the interdelay and interdelay like in first statement, first begin and end block?
Yeah.
What is the first statement?
It is a inter. No, sir, it is a interdelay. First one, and
First
in second one, in
first is interdelay.
Inter.
Okay, first is interdelay and second one is
Inter.
Okay, so what is the difference between inter and interdelay?
So interdelay, in intra we assign the delay in a same line, but in case of interdelay we assign the delay between the statements.
Okay. So from okay, so you two guys are giving the answer. Other people please tell the answer. What
Sir, I want to add that one point, sir.
Okay, sure.
Sir, in the first statement, the value of B at T is equal to 0 will be assigned to A after 5 time units. This is the meaning, sir. First statement. In the second statement, as 5 C is equal to 8 means the updated value of A is assigned to C after 5. That means after 10 time units overall. This is the meaning of first statement. Second statement tells that A is equal to hash B. As 5 B, it means the value of B at T is equal to 0 will be assigned to A after 5 time units, and the second statement C is equal to hash 5 A. It means the value of A which is in the T is equal to 0 will be the same, not the updated value. The old value, the initial value of A at T is equal to 0 will be assigned to C after 5 time units.
Okay. From and other question.
In the first one, the first statement executes after 5 time units, sir, and in the second block, it starts at time 0 and then it waits for 5 time units and then it assigns B value to A.
Okay. And other like Gopika, what you want to do?
Sir, I agree with what Bindu told, but one more thing is that whenever there is this changes that happen in the values of A or C, it will be the second one A is equal to hashtag 5B. Even after computing A, it waits for 5 seconds to be assigned to B. So even if there are any changes in A, it won't be missed when it is reflected to B.
Okay, so just you are including this point. Let me draw. Can you draw here something? Do you have any? No, I don't. Okay, just wait for a minute. Okay, is visible now? Hello?
Yes, sir. Yes, sir.
My screen is visible to all of you? Okay. It is visible now? Okay. This is 0, this is 2, this is 3, this is like 8, and this is 15. So I'm giving you like in first statement where we have the hash is equal to b. So like you guys take is this waveform as a b, and you have to draw the a. Okay, please everyone take this and draw the a for this according to first statement and according to second statement, and send me the link. Hello, Nakula. Nakula?
Hello, sir.
Yeah. So, did you get what I'm saying?
By using power gating
Okay,
and
so power gating, clock gating, and
by using isolation sets.
So what is the power gating? Just tell me.
Separating the blocks which are in ideal state from the power supply to save the power.
So if you are isolating the blocks, then maybe device performance is hamper or something like that happen.
Sorry, sir.
If you are giving in sleep mode in other hibernate mode, or like if you are not using that particular sub module, then if your device performance is going to hamper, and what your strategies, so you are going to giving the low power mode to other sub module. How you going to tackle this problem?
When my blocks are in ideal state, we are shutting down the power to that particular block only. When we are by taking one example, when we are on the call, we are muting all these some social media apps, something. We are disabling all the power to the subblocks. Wherever the power requirement is not necessary.
So do you know a very basic circuit for power gating, that how we can make the circuitry diagram for the power gating?
Yes, sir. I am sharing the image. I am sharing.
Okay.
Yes, please.
Okay, sure. Anyone get the answer? Hello?
Sir?
Bindu, Akash, Gopika, Anup, Raghavendra. Did you guys get the answer? Yeah, so just take an image and send me. I ask you very simple question, not in deep. Just I want to check your level, then I will start. Yeah.
Sir, at 5 nanoseconds, the B value will be 1, so A will be 1, sir.
Okay, and other than that?
And then at 10 nanoseconds, A will be 0, and then C will be 0.
Okay, and other people?
Yeah, sir, I am sending.
Okay, send. Okay, so this is yes. Okay, so Anup. Okay.
Yes, sir.
And what about one more guy, Raghavendra? Hello, Raghavendra. So other people, I want you to just do this question. Second question, always at the rate of this clause begin. Then Q1 is equal to A. Then Q2 is equal. Q2 is like Q1 is A is assigned to Q1 and Q1 is assigned to Q2. Okay, then end. I want to draw the hardware diagram of that module. Okay, Raghavan, Gopika, Bindu, and Amit. Are you get it? Hello?
Sir, there will be only one block, sir, since we are using here blocking statements. So first statement will be executed first, and then Q&A.
Actually, Bindu, just please try to understand. We have other people, so I want you to just draw the paper and send me, so I can give you feedback to everyone. Okay, Nagla. Hello, Nagla.
Sir.
Yeah, I get it. So can we manage power by using uh, at architecture level, even like we are using the binary number system. If we are using gray code instead of binary, then can we save the power? And what is your opinion? I want to know.
During conversion.
Actually, whenever we are trying to implement any and first we get an specification, then every circuit is based on the more or less on the FSM. Okay, so in FSM, if instead of using the binary number system, if we are using the gray code, then can we save the power? And what are you thinking that how can, if yes, then how we can save the power?
Okay.
Raghavendra, your answer is not correct. Okay. So, sure. Sorry. But yeah.
Correct, sir. Is it?
Is it it's not correct. Okay. So,
sir, the waveform which you have given, that is the waveform for B or?
I'm giving for the B. The waveform is.
Yes, sir. B. That means A is getting the same value updation same as B after adding 5 units delay. No, sir?
Yeah, that's the concept and that's the logic which is you are not getting here. Okay, I will tell you later.
Okay, sir.
Yeah. So Bindu, you have sent me logic that what is the logic of that. So just give me 1 minute. Hello. So Bindu had sent his answer for the first one, no? So Bindu, are you sure that your answer is correct?
Yes, sir.
Okay, you are sure.
Yeah.
Okay. Another people, please send. Okay. Only 2 people. I get answer only from the 2 people. Okay. So Bindu, then why are you thinking that this answer is like that? Can you explain? Yeah.
Can I? Since we are using blocking statements here,
Yeah.
they execute sequentially. That is one by one. So first of all, A is transferred to Q1, and then after that Q1 is transferred to Q2. So ultimately, Q2 has A value, so there will be only one block.
There will be only one block, and second person is who sent me this response. Anup.
Yes, sir.
Why are you thinking like that? Why are there is only one block?
Yeah, actually, if we suppose there is A is the input, so in a flip flop, whatever we
You can even speak in Hindi also.
Yeah,
there is
okay.
no problem.
Yeah, okay, sir. So whatever we send to A, to as it is Q equal to A, so whatever we will send the input as it is Q equal to 1.
Okay.
And other input Q, there is two in a flip flop, there is a one input, and Q and Q bar, there is a two output, we can say that.
Okay.
So in Q2 bar, suppose
I understand. So Gopika and Raghavendra, what is your answer?
So second one, sir, shift register.
So this I ask this.
Yeah.
So
Sir, always at positive edge of clock means that is always a running event, sir. Because positive edge of clock, the value of A is first assigned to the Q1, and the updated value of the Q1 is assigned to the Q2 after next execution, sir. That means the updated value.
Draw the hardware diagram in your pen. Take a pen paper and draw the hardware diagram. Then send me.
Sir, hardware I don't know, sir. Actually,
just draw the flip flop.
Okay, sir. Okay.
Just draw the flip flop.
Okay, sir.
Yeah, do it fast, please. Okay, and those who completed, then do all. Sorry, all this. Do for this. Okay. Those who completed first one, do for this block. Nagula, did you get the answer?
Yes, sir. But this gray code system will take more power, sir, because of more than 2 bits are toggling.
That's the listen to me carefully. That if we have like a 111, okay, after that we are transitioning to 1000, like 7 to 8. So here we are here 8 bit are changing. The 4 bit are flipping, like 0 to 1, 1 to 0, 4 bit are flipping. When there is a flipping flip the bits, then it will consume the power. So in gray code, between two sequential, sequential, there is only 1 bit flip. Okay, each time. So how can you justify that in gray code take more power? Did you get my question? Where is the problem?
Yes, sir. I got.
Yeah. So who sent me this?
Bindu, sir, me.
Bindu, okay. Raghavan, please, do it.
Sir, actually, I don't know the idea, sir. I have drawn simply a 2 deep flip flop.
Yeah.
I am not sure, sir. I'm not sure about that.
Just send me, no issue. Okay, and Raghavan. So all everyone is you haven't sent Raghavan, so I don't know about you have sent. So
yes, sir.
Everyone's answer is not right. Everyone is wrong. All of you, like Bindu, Gopika, Anup, and Raghavan, your answers are not correct for this block. Okay. Sorry, I have mistake here. I have not mentioned always, but you guys understand this is typo. Okay, so you all are wrong, and just do for the second one. Your everyone is answer is not right. Okay.
Sir, the second one I just sent now, sir. First one I sent before only.
Yeah. So your first one is wrong. Okay. The first one is not correct. Yeah.
Sir,
Yeah.
I send it second one.
Okay. Let me check. Your name?
Anup, sir.
Anup. Okay. So, Anup, your second one is also not right. Okay. Yeah. I'm not asking very like a rocket science and very tough question. I'm asking very simple question.
Yeah.
You are not enough confident in blocking and non-blocking, concurrent and sequential statement.
Yes, sir. Later we'll tell you the answer.
Okay, later you will tell you, and that's why we are having.
Yeah. Okay. Yes.
You are improving yourself. Where are you lagging? Okay.
Okay, sir.
So Gopika, you are not very silent. Why are you not?
I've sent the answers. I have nothing.
So good. So Raghavendra, you have sent me for the second one right now.
Actually, clarity, I don't have clarity. So once you once I know it, I can do. But really, I don't know, sir. I just know the concept. That's it, sir. This blocking means it will block the next consecutive statements. Non-blocking means all are executed parallelly. Only that much I know.
Okay. Bindu, like you have sent this one and this. Okay. So okay. So this. Okay. And like for second one, you all are clear. So I want you guys to draw for this one, last one. Okay. We have two walls block. Okay. Then draw for this. How the flip flop is work. Yeah.
So I'm a little bit confusing this binary and gray. I have to look up.
Okay. Just go through that. So tell me that how many power are there in low power design?
Two power, static and dynamic, sir.
Static and dynamic. So what is the static power?
Static power is the power dissipation when the device is in off state.
Device in off state. Okay.
Non-switching state.
Okay. So do you have any formula for calculation of static power?
Yes, sir, but no idea.
And what is the dynamic power?
Dynamic power, basically there are two types, static and switching power and short circuit power. This dynamic power comes when the device is on. Switching power means transition is from 0 to 1 or either 1 to 0.
So what is the formula for the switching power? And this factor and the factors are affecting the switching power. Hello. Anyone get the answer for this question? Okay.
So
Yeah.
basically, this dynamic code depends on mobility, oxide thickness, width, and W by L ratio, aspect ratio, and the
Yeah.
threshold voltage.
As I know that it will depend upon the frequency, VDD, and the load capacitor. You haven't gone through that? Like this is a very, and what is the short noise? I have know that there is short noise also. You have heard this.
Sorry, sir. Sir, I not got the question.
Short noise, short. SH
Short noise.
RT, short noise. Yeah.
So the last one I have said.
Got it. I'm asking some rocket science like like rocket science or something. Do you feel like that? Let me make the changes. So I'm going to make change like that. Just draw for this. Okay. Just draw the hardware diagram for this. Bindu? Hello, Bindu.
Yes.
Yeah, what is the problem? You are not sending the answers.
I could not figure out, sir.
These are tough questions, or this is very basic question. I'm asking from the project. I haven't started from your project Wall I know I also work on the like Vedic multiplier, Wallace tree, Dada, and some other like boot multiplier. We have more to ask. I have some more to ask you, but you are stuck here in very basic questions. And also for all other guys like Gopika, Anup, and Raghavan, you are also not have the crystal clear concept and like in basic questions.
And that is the problem in the designing of hardware. Yeah, theoretically
No,
they are
no,
understanding.
no. Actually, if a customer is customer, you talk to you in terms of hardware that I need this particular that hardware. So his functionality like that. He have the digital concept and this architecture level. So you have to implement in the hardware. So you should know about it. No, I'm not asking to draw like a risk processor and something like that. I'm very basic question. Draw the two flip flop. There are in each question you have only 2 or 1 flip flop, not more than that. So these concepts are not very tough at very high level. Actually, these questions are asking in the interview. That's why I'm asking. I'm not asking from the other. I don't want to divert you from the your goal. And this question has been asked in some interviews that I will ask you. Nagla, did you get the answer?
No, sir.
You didn't get the. So you don't know about the short noise. So tell me about if I have the like 3 volt VDD supply, and in some module I need 1.2 VDD volt supply. Okay.
Okay, sir. 1 point.
Uh, what?
Okay, sir. Continue.
Yeah. So how do you do like power flowing? Some modules require 5 volt, some module require 3 volt, and some module require 1.3 volt and some 0.7 volt. So how do you provide different power to different sub module? Then what are your like what is called and the concept behind it? I want to know. And other people, did you get any answer for this question like last one?
Yes, sir. Try.
Okay.
Sir, I sent sir just now.
Okay. Let me check. Hindu, your answer is not right. Sorry.
Okay, sir. Wait. I want to switch this. Just do for this one, okay? This is for this one also. For this it's okay. Okay. But everyone, please do for this one. See in the screen, right? Okay.
Sir, by using multi MVT cells, multiple threshold voltage cells, we can segregate and separate the voltage blocks.
So what are you saying? Please repeat.
MVT cells, by using MVT, HVT, LVT, we can separate.
Okay. So if we need different clocks like in different modules, then how do you do like what is it's called like clocking and something like that? I just like if we require different clock, so how do you plan for the clocks in different modules and IPs?
By virtual clocks, by generated clocks, and source clock, like this, sir. Deriving from the main clock, we are partitioning, we are making virtual clocks, generated clocks. By using the generated clock, we can divide or multiply with the source clock.
Okay. So if we have the clock f, so how can we get the clock f by 2? Okay, just take a pen and paper and draw it. And did anyone get the answer?
Yes, I have sent it.
Okay. For this one, I have highlighted.
Yes, sir.
Okay. Actually, I'm waiting to you guys to respond me first, so then I can finish it on time.
So I send it. Click.
Yeah. Let me check. I don't know why are you guys not able to answer this basic question correctly. Okay, no issue. So can you write one program for shift register and giving it? Okay.
So by using divide by 2 generated clock command, we can divide the frequency by 2.
So how do we get by 2 frequency, like you using counter, and what do you do, like? These are the D flip flop, okay? All are D flip flops. Okay, so I want you to write the logic for this 4D flip flop, work as a shift register. Only write the logic for that. Bindu, Gupika, Anup, and Raghavendra. Okay, so it will work as a shift register. Bindu, are you sure that your answer is?
Sir, no, sir. Just a minute, sir. I'll send again.
Okay. Dragon, are you able to make the F by 2 frequency from F and just use a flip flop? Use
Say F by 2, sir. F by 2.
Yeah. Use toggle flip flop and
Okay.
yeah.
Okay, sir.
Bindu, can you do it by using the non-blocking assignment? The blocking assignment.
Yes, sir. Yes.
Yeah, just try it and send me.
Sir, I shared. Can you check?
Okay, okay. Can you do it by using non-blocking statement? The blocking statement. Let's try to do it by blocking statement. Non-blocking, everyone can do it, but I want you guys to write logic for the blocking assignment. Using blocking assignment. Okay.
Okay.
In non-blocking assignment, it is easy just because of uh, the expression are evaluated in parallel, so that order of the statement is not important. So for non-blocking, you can write any logic. That's okay. But for the blocking, if you are able to write the what is the logic behind it, then it's good. I think. Okay, when your answer is right. Can we write in reverse order? Like B is equal to A, then A is assigned to B, then B is assigned to C, then C assigned to D, and D assigned to E in the reverse order. Hello, Bindu.
Yes, sir.
Can we write it in reverse order? Your statement which you are write in order. Can I reverse the order like A is assigned to B, then B is assigned to C?
Yes, sir. Because blocking statements are order dependent, so we can write it.
So can I write in reverse order though? Then this will also work as a shift register.
Sir, I have sent sir already.
So if we do write shift by one, and then last out the first flip flop of that input will be assigned to the direct output of the last flip flop.
Okay. Who is this?
Yes, sir.
Your name?
Anup, sir.
Anup. Okay. So, and Bindu, I just want to know that if we first write A is assigned to B,
Yes.
yeah, then B is assigned to C. Then
Then I
what?
think only one block will form, sir. We can't make shift register with 4 blocks. Like 4-bit, we can't make it, sir.
Okay. So it works as a single flip flop.
Yeah.
Okay. So who's this? Okay, Gopika. Actually, Gopika, I'm giving you the architect hardware, so you don't need to write in this way. You can simply assign values A to B and B to C, whatever. Okay. So, Gopika, can you tell me what is the polymorphism?
Answer.
What is the polymorphism?
Polymorphism is mm, I'm sorry, sir.
And what is the inheritance?
Inheritance is basically we will have a parent class, and from parent class we will be passing down classes or methods or routines into the other derived classes.
Okay. So if we want to in child class, if we want to change some changes and we don't want to reflect in the parent class, so what you do, what is your strategy? if we make some changes in the in child class, okay, so we don't want to reflect those changes in the parent class, then what we do?
We'll be using keywords like protect.
Okay, okay. Revise those concepts, please. Okay, okay. And Bindu, how do you make a wall stream? Like, how many bits are using?
Sir, I have made it using 16 bits, sir.
16 bit. So, do you know the concept behind wall stream? Are you?
Yeah. Yes, sir, I know. I would like to say just a minute. Sir, VLSI multiplier, there are so many multipliers before, like array multiplier, binary multiplier. So in this VLSI multiplier, we can reduce the number of computations. Speed will be increased, delay decreased. So in general conventional VLSI multiplier, we used parallel prefix adders to reduce area, sir. There will be 3 stages: parallel product generation, full adder, half adder addition, and carry adder.
Yeah, yeah,
But
but we have so many mid-level products like multi like what do you say after multiplications in between we have the many multiplication output.
yeah, yes, sir.
Yeah, yeah. So how do you like just draw the circuit diagram that what like logic diagram for that and say.
Sir, can I implement using a 4 bits, sir? 4 bit.
Yeah, yeah, yeah. Take a small bit. It's okay.
Okay, sir.
Okay. So Anup, hello.
Yes, sir. Yes, sir.
So what is your project you have completed?
Actually, we have completed memory design, that is dual port and single port, and other is synchronous FIFO also we have designed.
Synchronous FIFO. Okay, okay. So why we need why we need FIFO?
Yeah, actually, yeah. Normally, we know that the speed of transmitter is more than the receiver, and suppose the speed.
How can there is a difference between the speed of transmitter and receiver?
Yeah, yeah. What's it?
Why there is a like no synchronization between the receiver and transmitter?
Yeah. There is a problem in metastable problem.
Why metastability is coming in?
Yeah, actually, at the suppose in a setup and hold time in a between that period of time, and if the violation occurring that time, so if violation is occurring that time, so then there is a metastable problem will becomes.
Okay, okay. So metastability is coming, then there is a bit corruption. Okay.
Yeah.
So it will not not getting the right bit. So if I'm not getting the right bit, then FIFO is why we are using FIFO. FIFO is like
actually FIFO is a register. So suppose we are sending 8 bit and receiver receiving 5 bits and 3 bit are losing. So the remaining 3 bit.
So you are telling me the metastability. So metastability is like correcting the bits and we are not getting the right bit. So
yes.
And you are telling that we get the error, and so how you can going to correlate correlate between metastability, FIFO, and error? Actually, what are you trying to say?
Yeah, actually, we can correct it by using some one more flip. That is one is synchronizer. That is 2 flip-flop synchronizer. We can avoid the meta problem also.
So I'm just asking you that if we getting the wrong bit, so what is the problem? Why we need to store that wrong bit? If it is coming, then like as make it wrong bit. Then why you are using it? why there is a need for storing the bits.
Yeah, Actually, the information
Just listen to me. If bits is not getting right, okay, like a corrupted bit, so if you are storing in flip flop register, then it can it be like become error free, and it will be the original bit by storing in flip flop. Did you get my answer question?
Yes, I am getting, but just what I know, and suppose what are the actual information we are sending? If at the receiver end we are not getting same as it is what we are sending, so there is some.
Okay. Just try to make your concepts clear. Okay. So hello Raghavendra.
Yes, sir. Yes.
Okay. So how do you design elevator?
Elevator.
Yeah, using FSM or something else?
Yes, sir. Sir, elevator for fourth floor. The first step is we have to draw the state diagram as per the requirements,
Okay.
and then we should do some state assignments by using some state assignment techniques. Like so many state assignment techniques are there, sir. In synchronous one, we can do some using that state assignment. Then we can implement using that logic, sir. Only I know that
Okay.
one.
Okay. So how many always block you have used during the implementation of your FSM, and what FSM you have used?
Sir, this pipeline data, I did pipeline data, sir.
No, for elevator.
Yeah,
I'm asking how many always block you have used in elevator for the implementation of your finite state machine in Verilog.
Sir, one, I think one is sufficient, sir. Not that much clear, sir. I'm not that.
Actually, we are for the there is a concept like a process methodology, and where you are sometimes we are using three process, and one process. So three process mean three always block, two process mean two always block, one process is one always block. So for million Mure, there is a specific process methodology. Okay, just go through that and be more specific and be more clear what you have telling your interviewer that I have done this. Then you should be confident and know each and everything about that concept. Okay.
Okay.
Hello, Gopika. Yeah. So you have covered like Verilog system, Verilog and other things, but make a grip on that. Okay, just not covering is not sufficient. You should be you don't need to know each and everything, but whatever you know, you should be confident. Okay, I hardly find something that you have confidence on anything, and your concepts are not clear right now. Okay. So I have so many things in SVM UVM to ask you, but right now I find that and try to implement some projects also. Projects giving you more clarity. Okay. Hello Bindu, did you get the answer?
Yes, sir. Just a minute, sir. I'm doing it.
And other people, if you have any question from me, so please ask.
Sir, you have said, Amudu, you have asked one question. So can you tell the answer? What I should say if any interviewer will ask?
What for? What?
You are saying about people. Why do we?
Yeah. Actually, when we are transferring data, or when we are in like making transition from one clock domain to other clock domain, so there is a clock difference between one module to other module. So that's why difference between the clock, it is called the clock domain crossing. Means we are crossing one clock domain to other clock domain. Okay. So difference between the clock, one may be at sending the data from the higher frequency. Okay, another is receiving the data from the lower frequency. Okay, so in that case maybe there is a chance of data like we are getting more data from the transmitter side and receiver side. So receiver is not applicable to read those data at the speed of the transmitter side. So we need to collect those data somewhere now.
Yes,
like
yes.
like we have a tanky in our roof. So if water is coming from the pipeline, so we are not ready to consume all the water at the same time, so we are going to store it and after we will consume that. So flip flop is just like a water tank. Okay, we will store it and after that we will use after some time. Okay.
Okay, but sir, in case of synchronous people, the speed of receiver and transmitter work at the same rate.
Yeah, at the same rate. That's why
So why?
we need only one bit flip flop there.
So there is no need to store. There is no. I think there is no need to require people.
Just think that if a speed of your consumer and receiver is at the same, like you suppose that we are in a shop and there is so very crowdy, and if you are going somewhere, so whatever he's making at the same time cooking and people are ready to consume it, so he must be have some delay for 10 or 20, like whatever is required to make that particular dishes in one time. So he will make this and then give it, so at least he will ready to make a difference for at least 1 minute or 2 minutes. Okay, so that's the same, like I try to relate you for the like a general example. Okay, so there is also need for one flip flop in the synchronous. Yeah. Okay, and other question anyone have then ask?
So,
Yeah.
in the beginning, we had a question about FSM. You
Yeah.
said that you will give like what are the other points that could be discussed?
Yeah. Just uh, talk to Rajat and told him that I have covered the all. I have given the FSM lecture which is created by me. So just go to those lecture and you will find different that what you have studied till now and what is the industry is asking. Okay. Okay. And any other one have any question?
Sir, you have written the some question you have given to answer if you want to come. If we get the answer, then I'll match it. Okay, what is the correct?
Okay. So I will send you the answer in the after tomorrow I will send it. Okay.
Okay.
Actually today I am very much busy and
Okay, so no problem, no problem.
so
Sir, one last question, sir.
yeah.
Sir, regarding project part, we have done the projects pipeline ladder, some elevator by just simply from copying paste from any website. Do you think that is sufficient, or do we need to do little bit high level projects? That is sufficient, no, sir, to apply for off campus. While applying off campus, how much will be the level of project we should keep, and how much will be the conceptual clarity, sir? Just can you briefly tell me, sir?
Okay. So one is the favorite project and for industry. They are actually everyone knows that project like a risk five processor. Okay, so you should have very much clarity in the risk five processor, and each and everyone know about it. If you have the whole concept grip of the risk five processor, so you are able to answer at least 15 minutes. So in 15 minutes you are continuously giving the answer, then it will be going to make a good performance and huge impact that you are the deserving candidate if you are able to answer the correctly of all the risk five related question to risk five. So I have completed the risk five and just ask the Rajat that he will provide the like a background of the risk five processor. Okay, so you have to complete the risk five processor, then the second one is like traffic light controller, then synchronous people. And elevator is also a good project. So whatever you do, you should know the things behind it. Like in elevator, you should know their FSM, milling machine, moving machine, then the sequence detector, and what is the process methodology and how do you going to implement. So the behind the things you should know. Okay.
Okay.
Okay. Other than whatever you are mentioning in your resume, you should have the very good grip on that. Okay. And any other question from your side? Anyone have any other question? Bindu, are you able to draw the like?
Sir, yes, I have drawn sent you the picture.
Okay, okay. Do you have any question from me? For me, like I
Sir,
yeah.
sir, I'm good in, I don't know, sir, just now you kept that blocking and not blocking. I just blanked it there only.
What I'm not getting
Sir,
is
when we are having two always blocks, they execute parallelly, no, sir.
yeah, they will execute parallelly. Okay.
Then if we use blocking statements, either blocking statements or non-blocking statements inside them, they will be having the same since the schematic. Sir.
No, no, they will not having the same schematic. That's the concept now. So you should not clear about the blocking and unblocking. Okay, I will send the answers to you. Okay, I will make a PDF and send to you guys.
Sir, and
Yeah.
also,
What?
sir, we will be having race conditions in blocking, sir. Can we still use them when we are using two always blocks?
Actually, why we are having the race condition for every block there will be we will assign like here this always block is running for the different flip flop and this always is going to execute for the different flip flop. They will assign the different hardware. So there is
Okay.
no concept of the race and the other thing. Okay, so and I'm not going in deep of like your projects and all, and also I have left a question from like like aptitude question. Okay, so you should also know those questions also. Okay, and what are your strength and hobbies and what are your weakness. Also try to know the answers of what are your strengths and weakness and hobbies interest. So after that now I'm feeling that you are not ready for the I am Bindu in your case like you are in first year, so you are in on right track as I'm saying. So no need to worry, just please continue. Okay.
Yes,
And
sir. Sir, we are having internships, sir. In this month we are getting internship. For that I am preparing.
okay. If for internship you mentioned the risk 5 processor, just talk to Rajat and say that please give me the access of the risk 5 processor. And once completed the risk 5 processor, then ping me. I will tell you that where do you get the code of that processor. Okay.
Okay.
Okay, for everyone, this is the for everyone. Once completed the basic behind the risk 5 processor, then I will explain the code. Okay, so once you have take 2 or 3 week and completely the things which I have mentioned. After that, we will take again. I will. Okay, guys. So no, I think now it's enough. And shall I leave?
Yes, sir.
Yes,
Thank you,
sir.
sir.
Thank you.
You will. Bye, guys.
Okay, thanks.